I'm going to explain about pulse width modulation. As you know that the pulse width modulation means the carrier width is changing according to the message signal. The carrier width is changing according to the message signal. I'll explain clearly. So here, before that, you should know what are the types of modulations. Here you can see this. So these are the continuous wave modulations and this is pulse modulation. And coming to here, the amplitude modulations, continuous wave modulations are amplitude modulation, frequency modulation, and phase modulation. And here, the pulse modulation is again divided into analog and digital modulation techniques. So here in this, so it is an pulse amplitude modulation again that is pulse width modulation, pulse position modulation techniques. And of course here the pulse digital modulation techniques are that is ASK amplitude shift keying and FSK frequency shift keying and PSK phase shift keying. So these are the different types of modulations. All the modulations are used to convert from one form to another form. So in all the modulations, this is message signal is common, either analog or digital, M of t, and again we need to take one carrier or duplicate signal. So I am taking this is named as carrier or else duplicate. If it is both are analog, that is analog modulation. So if it is pulse, carrier is pulse, so then it is pulse modulation techniques. So if you used pulse, then it is a pulse modulation techniques. If the carrier is pulse, then it is named as pulse modulation techniques. If both are digital, then it is called as digital modulation. So here you can see this pulse width modulations. This is here we are giving, for example, audio signal we are giving here. So this is an audio signal message, and here we need to give the carrier again. So here in this you can see this the carrier signal. So this is an message signal M of t, M of t. This is an message and this is an carrier signal. So carrier is a pulse and message is a analog signal where it is here. So here this is the message signal and this is an carrier signal. So you will get the amplitude modulator signal here. What is the amplitude modulation signal? So you will get like this. This is an amplitude modulated signal. The carrier is varied according to the given message signal, given message. So this is an amplitude message signal. So again we are taking one more sawtooth waveform to get the pulse width modulation. So here I am taking sawtooth. So this is the sawtooth waveform, sawtooth. So this is an sawtooth waveform. Again one more carrier you are taking. So both are adding here. You can see this here. This sawtooth waveform again you are taking. So this is an amplitude modulated pulse amplitude PAM signal. After PAM again we are adding, that is sawtooth waveform. This is the sawtooth waveform, sawtooth. So this pulse plus that is carrier, so it is adding and again it is adding. So based on this you can see this is the resultant signal. Based on the amplitude, the width is changing. If the amplitude is less, the width is less. If the amplitude is more, the width is more. Here you can see this. Width is increasing. So like this, the width of the pulse is changing according to the message signal. So this is about the pulse width modulation. So this is the block diagram for that. So we are getting, this is the message signal modulating with the carrier pulse, and you will get the amplitude modulated signal here. This is an PM, pulse amplitude modulation. Again you are taking one more sawtooth to change the width, so you will get the, that is pulse width modulated output, depends on the amplitude of the PAM, so you will get the width is changing. So this is the final output. Thank you.